Here is a short review of what we know about sampling distributions for the sample mean. Okay, so there's three things you need to worry about. First of all is your original population. So I often like to put in the word original here because that helps me remember this is like the original population, or like your original data. It's basically all of the data values that you would be interested in. You have a mean mu and a standard deviation sigma. Then you have the option of taking just one single sample, just a normal, well, like not normal and statistically normal, but just an ordinary, nothing special about it sample, one sample. You take a small sample of values from the population that will have a mean of x bar. Now hopefully this mean is going to be close to the population mean mu, because in later chapters we're going to use the sample mean x bar to estimate the population mean mu. You'll have your sample standard deviation s, which again hopefully is close to your population standard deviation sigma. Because again, we want to use the sample mean and standard deviation to estimate the population mean and standard deviation. And the bigger the sample size, the better the estimates we'll get. Now, one thing I've noticed people keep trying to put in the discussions is they keep saying that the standard deviation of the sample gets smaller as n gets bigger, and that's not true, because s should still be close to sigma no matter how big your sample size is. Now, it will be a better estimate, so it will be closer as n gets bigger, but it shouldn't actually be getting smaller and smaller and smaller as n gets bigger. That's something different. So that comes into play here of all the possible sample means, because every sample we would take would give us a different sample mean. So if you look at every single possible sample mean, that would be your sampling distribution. It's a way to describe all the possible sample means. And we do this not because we would ever take all the possible samples, but to try and figure out what would be happening theoretically if we did. So of all the possible sample means, that's your sampling distribution. The shape of all the possible sample means has two options. One, if the population is normal, then the shape of all the possible sample means will be normal, no matter what your sample size. And if the sample size is at least 30, then the shape of all the possible sample means will be approximately normal. Again, kind of no matter what your original population looked like. So you have those two categories, and you have a third category that people keep asking about. So if the data is not normal and n is less than 30, then the sample means might not be normal, and you shouldn't use the normal distribution to find probabilities. Okay, so three different situations. Now, for all those possible sample means, there's the mean, or the average, of all the possible sample means. So the mean of all the possible sample means is just equal to your mean of your original population. Now, standard deviation of all the possible sample means would be the standard deviation of the original population divided by the square root of n. So this is what gets smaller as n gets bigger. So it gets small as your sample size gets big. This is the only thing that gets small as n gets big. Now, I've also been hearing people try and say that as n gets big, if n is at least 30, then your sample will be normal. That's not true. Okay. So for your one single sample, the shape of the sample, the shape of just one sample of the action. So let's see, the shape of one sample, the shape of the data in one sample is probably going to hopefully be close to the shape of the population. Okay. It does not have to look normal if n is greater than 30. The only thing that has to look normal is the shape of all the possible sample means. The actual sample itself does not have to look normal, and the standard deviation doesn't have to get small as n gets big. So those are just some things I've been hearing people say.